to be session 1, continuation, unit 7, if I didn't say that. So, if you could put U7 as in unit 7, session 1, that's official title of my thing somewhere. And we begin. Let's go. We'll start with the video where to find the sine of the cosine of 60 degrees. You fold the top finger, which people at home cannot see. The cosine of 60 degrees is radical 1 over 2. It's always over 2. The sine of 60 degrees is radical 3 over 2. So the lady's going to show it. I'm trying to get you to cope onto tangent, because that's going to be on the new test. The cosine, the top fingers, of 45 is radical 2, always over 2. The sine of 45 degrees is radical 2 over 2. The last one of the three famous. The cosine of 30 degrees is radical 3 over 2, always over 2. And lastly, the sine of 30 degrees is radical 1 over 2. I should note that whenever it's a radical 1 over the 2, on a real test they will write 1 because the square root of 1 is just 1. For me, so you don't have to remember extra stuff. If you put all the tops under a house, you're good to go. As a math teacher, I won't mark you wrong. The teacher would mark you wrong for radical 1 over 2. Recording.
The more difficult one is tangent. Remember that tangent is sine over cosine. Well, if the fingers went cosine comma sine, then when I flip back my pi over 3 finger, which is my pointer finger, cosine comma sine, if I flip my hand, I now have sine fingers over cosine fingers. So tangent is going to be root fingers over root fingers. So I have, when I flip my hands, root 3 over root 1. And we know that root 3 over root 1 reduces to root 3. Root 3 is your answer.
That's very cotangent.
If you wanted to do cotangent of pi over 3, you would take and flip back your pointer finger. Do not flip your hand, and then do root fingers over root fingers.
What?
So it would be root 1 over root 3, or 1 over root 3. I will do different quadrants on another video.
Cool. I'm here to say to you what it is I know to get the right answer on the test. Which is what you want, that's what I want. Sometimes the test will say, what is the sine of 30? That is code talk for what is the red number at 30 degrees. If you understand what that's asking you, and you have a chart, nice and easy. Can someone say what the sine is at 30?
1 over 2.
1 over 2, also known as 1/2. He is correct. Anybody know what the sine is at someone different, at 150? 1 over 2, also known as 1/2. There it is. I want you to notice that they're both 1/2 because the sine essentially is the y-axis. That is sine. So when you go up this way, you're doing sine. So this 30 is the same height up as is this 150 from the ground level. Okay, they're both in the same position going up. You will also notice that the sine of 330, negative 1/2, is the same as the sine of 210. Same concept. From the ground level, if you were to go underground, as in the movie 33, which I won't comment on because I'm focused today. Let it go. All right. I'm not going to mention that Antonio Banderas was in that movie with, all right, I'm moving. Again, they're the same distance underground. The movie is underground. It's a good connection. I'll leave it alone. Okay. So sine, the red numbers, are about going up and down. Cosine, the blue numbers are about going left or right. In other words, someone who hasn't answered yet, please tell me what the cosine of 60 is, the blue number for 60.
1 over 2.
1 over 2. Great, also known as 1/2. You are not impressive at all. All right, so here's the deal. There's the 1/2 for 60. How do I know? Because, again, on the ground level, how far you go left or right, just like the x-axis is cosine. Someone else, someone different, tell me another place where the cosine is also 1/2. We know it's at 60. There's 1/2. Someone different who hasn't answered yet, tell me where you find 1/2. That is also, where the cosine is also 1/2. 300 right down there. You can see it. So if you have a chart, the questions I'm asking you are like baby questions. It's like hide and seek. Can you find the positive 1/2 for the blues? Yeah, here they are. You sure it's not over here? No, that's a negative. That's a negative. So you only have a few choices. And again, cosine, when you go from left to right, it's positive this way. It is also your x-axis, much like sine is your y. In other words, they teach you stuff you already know, just giving it a new name. Like, no, I can't even. Anyway, so we got that. Let's back in coach. If I said, what is the cosine, you won't have the chart initially. What is the cosine of 60 degrees? Chart, you look up there, no big deal. What is the blue number at 60 degrees? Oh, it's 1/2. Fingers, what is the blue number, the cosine? Well, it's going to be radical 1 over 2. That'll be the top guy. Okay. What is the sine of 60 degrees? It's the bottom guy. Radical 3 over 2. There it is. Chart, super easy. No chart. You got to memorize the little hand thing. All right, let's try one more time before I go to the page where the hard work begins. The cosine of a 30 degrees, cosine of 30, is radical 3. There he is, radical 3 over 2. The sine of 30 is a radical 1 over 2. Again, they'll never put the radical 1 over 2. So we are going forward. What is the answer when I tell you the degree? If I tell you 30, can you give me the 2 answers? If I give you 45, can you give me the 2 answers? If I give you a 60, can you give me the 2 answers? That's forward. They're going to ask you to do it backwards. They're going to say something like this. You get to use your chart so you know how easy it is. If you won't have a chart to do the first time, here we go. Someone tell me one of the 2 degrees where cosine is 30. No, sorry, scratch that. Tell me the degree where the sine is a radical 2 over 2. 45 is one of the degrees where the sine, did I say sine or cosine? I know. Sine is radical 2 over 2. He's a smart guy. That's good. If we're in the math phase, you might get something. All right. In any case, that is a place at 45 where it happens. Don't answer the second one. There will always be 2 on your test. You'll be required to put both answers. Where's the other place where the sine is a positive radical 2 over 2, somewhat different than
135.
This is 135, and there it is. If you have a chart, it's easy to find. The first answer, though, you'll be required to do it by finger. You'll have to wait for the other one unless you have them memorized. And if you do, I'm impressed by you. If you have memorized that the reference angle for these 2 guys is 45 and 135, or these 2 partners, they'll be partners. But who's going to know the other partner unless you're like a super math person? And right now, none of us in this room qualifies as math people. That's for the record. Unless you're hiding it. And if you are, why hide? Sine theta equals 1/2 means what degree, theta represents degree in the world of math. Theta is a Greek letter, like we have ABC, they have alpha, beta, gamma, delta, and theta is like around the T section, but I don't think they have 26 letters in their alphabet. Nonetheless, just like it would be an X, it represents a degree. Hey, what degree for sine spits out a red 1/2. What degree, don't look at your chart, what degree for sine spits out a red 1/2? I'm doing this with fingers, and even though she says already, but if I were doing it with fingers, in order to get a sine to be 1/2, I need the bottom number, the number after the bent finger, to be a 1. So when I bend this finger here, I win. There's a 1 for sine. So let's see. Eventually, once you get used to it, it'll be easy, but this original part would be a little clumsy. Sine is the second one. If I were to bend this finger here, I get a 1 at the bottom. Hooray. Radical 1/2, that is sine. The question is, what degree does this finger represent? It does represent 30. You only have 3 choices, 30, 45, and 60. 30, 45, 60. So the correct answer for this problem is, in fact, 30 degrees. That is, at 30 degrees, the answer will equal a 1/2. So you're going backwards. Normally say, hey, at 30 degrees, how much is cosine? How much is sine? Now here's the problem, and apparently if you use a calculator to get this answer, even though we will be using hands, they say it only gives one answer because there are 2 answers. There is another place where the red 1/2 is also a positive for the sine. Now this is where you'll need your chart. Look at your chart. Who's the partner? I think it should be the 150 goes across. This is on the high section. Look at your chart. Where's the other place that you get a the second coordinate? The second number of the coordinate is a
150.
Is it 150? The 30 is the more important part to me because the 30 you have to do on your own. The 150, when it's time to use your notes, you'll pull out your notes and you'll find out the partner. If you don't have the original guide, you don't know who the partner's going to be. I guess you could just look on there. So my hope is that you still do part of it by hand. Let's pause. Do it. Here's my plan. The cosine of some degree gives me a negative radical 2/2. If it were a positive radical 2/2, I'm not afraid of it. A cosine, I know radical 2/2 is always bending the middle one, and I get the 2/2. So 45 starts me off on this problem. And I'm going to write down 45, though I know 45 can't be the right answer. Some of you don't know why I know it, but I do know it. I'll try and say it to you in a second. This is a blue. You know it? You know what? Yeah, because you can't go to the right, and 45 is in that first quadrant. So Milo knows it. I'll tell Brian he chose right. So this gets me the 2/2 that I need, so I know to begin guessing, and I will want 3 answers. I know this will be the finger answer. So on your test, for sure, I'll always see a finger answer. I'll probably ask you to put it in a square. The one you got before the chart. So once I do that, I know 45 is one of them. Now please go to the chart. Go to the chart to find out where cosine is a negative radical 2/2. There are 2 places where it will be that. Find them and then tangent. The lady said I have to put my fingers in such a way that when I flip them, there's a 3 on the top. 3 on the bottom. Let me think for a moment. To get a 3 on the top, I know I fold this finger so I have 3 on the bottom. So when I flip it, I have a 3 on the top, but now I got a 3 and a 1, but they have a 3 on the bottom. Oh, they gave a hard one. I'm going to say it to you. I mean, just take my fake answer, but eventually teach you the real way to get it. To get a 3 on the bottom and a radical on the top, it goes like this. Yeah, here we go. I'm going to fold this finger so I can get a 1 on the bottom. When you get that 1 on the bottom, that's cool because I'm going to flip it to get the 3 on the bottom. I need a 3 on the bottom to begin with. By flipping it to get a 3 on the bottom, this is radical 3 over a radical 1. I'm sorry, below radical 1. So radical 1 on the top, radical 3 on the bottom. Well, how does that give me a regular 3? If there's a 1 on the top and there's a 3 on the bottom, there's a thing called rationalization. Anybody ever heard of rationalization? Good, nobody but me, that's cool. And what that means is, in a fraction, you can't have a radical in the bottom. How do you get rid of a radical in the bottom? You multiply that radical times itself. That is, if there's a radical 3 on the bottom, I'm multiplying radical 3 times radical 3, which turns it magically into a regular 3. And whatever you do on the bottom, you must do on the top. That is, if I multiply radical 3 on the bottom, I must multiply a radical 3 on the top, and 1 times radical 3 is a radical 3. So this is a terrible problem. If you have to miss one, guess what? He's a good candidate. You will have heard it. You didn't see it. At some point, I made it for a second. Oh, chart it. Save that one till the end. Oh, do this on your paper. Don't say it out loud so not everybody knows it. Oh, never mind. Dang, I thought I won. Never mind. You had to do it by hand. Let's start with a radical. What did I want? I wanted a 1. Radical 1. Yeah, radical 1 over radical 3. I get to feel smart while I'm doing this, because if someone's walking by and seen all this, I'm like, what, that guy must be so smart. No, he just remembers junk. All right, I'm going to rationalize this problem. What does he mean rationalize? So put the word rationalize over it in blue. Please, Thomas, rationalize it. Somebody just made that one up. Please rationalize it. How do you rationalize? It means to get rid of the radical in the denominator. To have a radical in the denominator, something's wrong. I'm not quite sure what's wrong with that, but I learned in math that you're not supposed to have it there. To rationalize it, you multiply the bottom by the same radical. Because some people know 3 times 3 is 9, the square root of 3. And rather the square root of 9 will be a 3. The other way of thinking of it is, if we multiply the two radicals times each other, they're identical, the number inside just pops out. That's the way I think of it. What you do to the bottom, you must do to the top. That's fractions, which kids love. Equal sign it? Sure. So here we go. What do I have on the bottom in red? Radical 3 times radical 3. I'll do the long version. On the top, radical 1 times radical 3, inside times inside. Anybody know the square root of 9? Yeah. I don't even know what I just did. Oh, okay. I'll pause it. Here's a lot of work that I did in this section here. No explanation. You should have been in class. Question. Because they asked the question here using radians, that is, there are pi's in the answer, I gave the answer in degrees, technically, and then have to change this 30 degrees into radians, this 150 into radians, by multiplying it times, what is it, pi over 180. But for now, let's just get this answer, and then we'll decide what we're going to do when it's test time. More than likely, I'm going to require you to do what they want you to do, which is switch it, because in this problem here, oh, that's bad. Oh, that's good, right there. You'll notice here that they ask, can I not move to the next slide? Yeah, here it is. Here, when they give you 360s, that means when you get the answer, you can keep it as a regular 30 or 150. All right, let me do this problem real fast. The hard one is going to be this one here. That's going to take a lot of our time. Here we go. We're about to do the same thing, but now they're like, that other stuff is so easy. Those kids, why would you give them baby problems? Let's make it super hard. By super hard, they mean let's add an extra number on the side of the sign. Before you can do the finger thing, you have to have sine or cosine alone. They need to be isolated. Just like that one girl in junior high who treated her so wrong. Her name was Marshana. I know her now. She's all grown up. Oh, mean girls. Mean girls. And clearly, some of the mean girls have to be cute, and then the other semi-cute ones are not cute at all, but they knew her since kinder. They get to be in the good group, and then when they be mean to the one girl, who generally is not super cute, then the other girl's like, yeah, I hate her too! And then the top girl, she lets her in. You know what, girl? You're okay with me. And the other goes, no, you're okay with me too. Yeah, no. So whatever she decides, and then the girl offends the lead girl. And what does the lead girl do? You know what? Get out of my life. You are dead to me. And I'm good with that. No, dead to me too. She was dead before. She wasn't even alive. Right. It was terrible as a junior high teacher watching that. So I said to Marshana, you don't even need that. They're not even nice girls. I know, Marshana, I know. And then when the mean girls let her back in, and she's friends with them, but who wants to be alone at recess time? You know, who wants to be alone? In any case, let's see. Here's what we're going to do. We're going to isolate Sine X, because Sine X doesn't even look good. Unless you're a good person, be nice to them. Then that'd be like being friends with like Will I Am. I think he was isolated when he was a kid. But now he's all like famous, wearing crazy junk. Because again, during that time of isolation, he lost his mind. But he's a big deal now. So if you were friends with Will I Am during the days when people are mean to him, now you're his friend that he's a big star. If you don't know who Will I Am is, you probably were mean to him. All right, here goes. You got sine x equals the 1/2. What did Thomas just do while he was talking? Yeah, I was working and talking. I'm solving for sine x. In other words, I'm getting sine x alone. Once I get sine x alone, I'm back to the fingers. I'm saying to myself, for the red numbers, what red numbers? These red numbers. Now I'm not even writing in color. For the my color chart, I wish I had made yours in color too. So now I got to pay extra for the ink. I just printed out the color one, but I didn't, so I'm sorry. To get sine, hey, when can I make sine 1/2? Let's see, if I fold this finger down, oh, shoot, I keep getting it right every time. I need the guys after the bent finger to be a 1 over the 2. I did it. Just did it. Anybody know what degree this finger represents? Yeah. Hey, what degree does x need to be so that when I bend my fingers, it will produce a sine that is a 1/2? The answer is 30 degrees.
Isn't there 3 on top?
For cosine, you are correct. The 3 is on top. Sine always follows the bent finger, so it's cosine, comma, sine. I wish I could call this a comma. Cosine, comma, sine. So the bottom guy gets to be sine, top guys get to be cosine.
But there's 3 fingers on top, though, isn't there? There's a down and
Yes, you are correct. It is 3 fingers. The question I would ask you is, are these 3 fingers for sine, or are they for cosine? What would you say?
Sine.
All right, you're close.
Closest.
Yeah, boom, nailed it. Second time. Look at you. All right, so yeah, it's true. You just have to remember that. These guys belong to cosine. These guys belong to sine. And they both go over 2. 3 over 2, 1 over 2. Do me a favor, find the chart, find the partner, please. To find the partner, to find that, usually you subtract something. In other words, you do 180 minus the reference angle will get you the other side. In other words, he's 30, 180 minus 30 is 150. Is it 150? Yeah. So the way to do it, just whoever your teacher was, he didn't stress it. He knew on the first test, maybe they weren't going to be hardcore on it that much. It could help them later, but what if they had a little chart? Let me use a chart. All right. I'm going to turn these radicals into letters, because you're used to letters. Then we'll do the same things we did the letters that you're used to with the radicals. What is he talking about? Here we go. Solve for y. You guys, the radical 2's are x's. It's not going to be good either. It's an ugly problem. I'll still change it, because I need this alone. Y equals mx plus b. So we're going to pretend that you're a y. Any place I see a radical 2, I'm going to make that the letter x. So negative x. And you get to be an x. It's not going to make that much easier. Over 2. Here is your task while I'm looking for papers. Solve for y. In other words, do smart. Y. Do blue x's. Black on the equal, black on that, black on that, black on black prime. All right, and then here we go. Just do that in. All right, so here we got here. This thing is too high. All right, so they go together. So obviously, here's all I'm going to do. Move this junk to the other side. Y is along for where I went. Yeah, felt easy, didn't it? It's not that easy, but at least it feels that way. So what am I going to do? Let me ask someone. The official way to get rid of this my negative x squared over 2 is to do what? Multiply, add, subtract, or divide. It is to add. It is weird. Some people kind of want to subtract because of this plus sign, but the negative sign in front of it makes you have to add. So I added in red. So now I'm left with this y equals this negative x plus x over 2. Those who hate fractions, this is the time that I begin hating it. Step one, if you're adding something to a fraction, you need to turn the other thing into a fraction. How do I turn that negative x into a fraction, anybody?
Put it over 1.
Put it over 1, there you go, because it's a hidden 1. Anything divided by 1 is just that thing, therefore that thing, if it were written in fraction form, would be that thing over 1. What's the common denominator between 1 and 2? 2. All this work is going to be just to get one baby answer. So if you have to sacrifice this guy and his friend who comes after his work doing, it's going to take me another 6 minutes to do this. 2 is right, so now I'm going to just try and do it without speaking or without asking questions. Here we go. Tick, 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 tick. To turn that blue 1, to turn this blue 1 into a 2, I multiply 2 on the bottom here, 2 on the bottom here. From there, on top, 2 times a negative x is a negative 2x all over 2, plus that original x squared, or x over 2. Hey, what do you do next, Thomas? Well, when the denominator is the same, you can just add the top stuff and keep it over that same 2. What do you mean? I mean do negative 2x plus x all over 2. And then I ask someone out loud, even though I'm not supposed to, remember what negative 2x plus x equals?
Negative x.
Negative x, correct. It's a negative 1, negative 2 plus 1 is a negative 1, but you don't put a 1 in front of an x because math people want you to be confused all the time. Alright. Do it again with the radical. I'm going to write over here what the answer is, like what just happened, what did we come up with? Technically, wherever I see an x, hopefully you know it represents, I said that x, I was going to replace it, the radical 2 would be replaced with an x, the y would be replaced, or the cosine would be replaced with a y. So, what I have is the following. Wherever I see a y, I'm going to put cosine x. Wherever I see an x, I'm going to put a radical 2. I'm going to write this and see what they think about it. Y equals all this junk here. Y equals the blue stuff, negative x over 2. By the way, if you're following any of this, you should feel really good inside, not because you're trying to understand, but because you're like, wait a second, I think I know what he's talking about a little bit. That's what math should do for you. It should make you feel good about understanding half of something, a negative radical 2, and I'm going to pause so you can look at it, all over 2. Take a moment, look at the other stuff. Anytime you see a radical in these problems, make it the letter x because the radical operates like a variable. Anytime you see the thing you're trying to isolate, tan x, that whole thing, make it a y, and that way you're back to solve for y, and y equals mx plus b. You're back to an old school problem. So here's how I'm changing this. The tan x, you're a y. All the radical 3's, you're an x. Everybody else, you're just black. You're a black. You're a black 3, and you're a black 2. Now, if I wasn't Latino, I'd be offended by that. Fortunately, I am, and the laughter isn't whatever. But that's it on purpose, of course. Dang, 28 minutes? Ain't nobody watching that video for 28 minutes. Oh, does it? Oh, shoot. All right, here it comes. Hopefully, you did some work instead of listening to me. If you didn't, that's your life. I'm not responsible for that. All right, here comes. Let's see. Let's subtract the x from both sides. Yeah. 3y equals, anybody know what 2 minus 1 is?
Negative.
Yeah. You want to be negative, but this time it's positive. I appreciate that, though. I'm going to divide that 3 on both sides. 1 with y equals an x over a 3. That part should be easy. And then, safe was coming around. Here's the beauty of this thing. Now, over here, dang, sometimes I feel like a good teacher. Over here, y equals the tan x. And I said that the x's were, we substitute them to make them just, what were they, radical 3's. Watch what happens now. Instead of having to do the work with radicals that we're not used to, we come back and put in the stuff where it was. Let me make that y red so it feel, better. So here it comes. So the y is a tan x. Where I see a y, tan x. right now you guys are smarter than most students, especially here at Austin, but even at traditional school. Not everybody's going to Algebra 2B. Well, maybe they are. Required for 3 years of math. Here's the answer to this question right here. The question is, hey, what does the degree need to be so that when I did the tan, I wound up with a radical 3 over 3? Let's see what I got here. I need a 3 on the bottom, 1 on the top. 30, dang it, that's so sweet. When I swing it down, there's that 3 on the bottom that I have to rationalize to get it back up to the top. Oh, man. 30. 30 is the answer. And it probably has a partner, and I don't know who the partner is. I'm going to put 150. We've been putting 150 with the 30s all along. But I don't know if that's true. I'm going to put 150 with a question mark. And save it.